Momentum, an ever-present power forging the pace of the future, expanding at an exponential rate. But this year, there's more to it. The world is now riding a wave fueled by the promise of AI, all driven by developers. Today, an ecosystem flourishes based on the commitment to openness, choice, and trust, empowering all within it to raise new waves, disrupt expectations, and create a world where innovation knows no bounds.
Welcome to Innovation Live. It's day 2 here at the San Jose Convention Center. Yesterday we heard from Pat about the vision. Today it's all about the execution. CTO Greg Lavender will keynote and let us know how developers should be prepared to respond to the convergence of AI, software, and security. But before that, we'll hear from Arun Gupta about Intel's open software initiatives, followed by a look at startups partnering with Intel. We'll also see one of the coolest demos on the showcase floor and the hackathon happening in the clubhouse space. Joining me again out in the showcase is Tony Mongkolsmai. Welcome back, Tony. Bring us up to speed.
Well, yesterday I walked around and I saw a lot of the great hardware demos that Pat talked about. We saw UCI, CXL, a lot of cool hardware technology. Today we're going to focus a little bit more on developers and software. So we saw Intel Ignite yesterday, but as you mentioned, we're also going to highlight some of our other programs like AI Disruptors, Intel Capital, and Intel Liftoff for Startups. Additionally, Madeline, as you mentioned, we've got really one of the great demos that you'll ever find, designing the modern AI studio. We're going to take people through that and see all of the amazing things we're building for content creators.
It's going to be a busy day, so let's get started. With me on set is Arun Gupta, Vice President and General Manager for Open Ecosystem here at Intel. Arun, thanks for being here.
I'm very happy to be here.
It's always a pleasure to talk to you, especially during this event.
I love it. When this is innovation, this is our developer event, what's not to be excited about?
That's absolutely right. Why is open so important?
Open is very important to Intel, and it's nothing new to Intel. If you think about it, we've been doing open ecosystem for over 20 years. There's a lot of legacy, a lot of history that we have been doing over here. There are 3 reasons why open matters. First of all, our customers who consume Intel silicon, whether in a cloud, in a data center, in an edge, in a device, they expect that the open source frameworks work out of the box in the most optimal manner. So that's where Intel contributes to 300 plus open source projects. We are part of the 700 plus open source foundations. And that's the element that is super important for us. That's why open matters to us, because open creates a ubiquitous horizontal choice for everybody else around the world. So that's one. The second is, as I started digging deeper into it, it creates a horizontal platform. You are no longer locked to a vertical walled garden. It provides open, choice, and trust to the customers, which actually makes it much more compelling for them to make a choice that matters to them, as opposed to dictated by a vendor. And the third element, which I talked about a little bit earlier, is what we in the open source world call as chop wood, carry water. This is a Zen phrase which says, before enlightenment, do chop wood, carry water, and after enlightenment, do chop wood, carry water. In the open source world, what that really means is, this is the non-essential work, very much relevant to keep the open ecosystem thriving. These are positions on governing boards. These are positions on technical oversight committees. These are working group leads. These are conference committee chairs. And Intel is in several leadership positions over several years to make sure we make open ecosystem thrive, because that's successful for us, for our customers, our partners, our developers.
What is Intel's role in this recent LLM explosion?
Yeah, absolutely. If you think about it, Intel's role really here is bringing AI to everywhere.
Everywhere.
No matter where it is, data center, cloud, edge, PC, you name it. We want to bring AI over there. And you heard from Pat yesterday, we saw some wonderful demos of Lunar Lake, Meteor Lake, and all. Those platforms are just amazing. So first thing that we want to do in LLM explosion is, we really want to democratize AI. We want to bring AI everywhere on all of these platforms, independent of where they sit. The second part really here is how we are looking at it to keep it as an open ecosystem, because LLM explosion is happening everywhere, but it again needs to be done in an open choice and trust manner.
Right.
That is super important. And the third element really here is, which we heard about Dr. Feifei Li's, discussion with Lama Nachman yesterday on being trusted, how to be responsible, how to be ethical part of it. So those are sort of the three key elements, and in each of those, we are working with a large range of developers, customers, partners, to make it successful for the entire industry, essentially.
Well, you mentioned this large range, and I think you said earlier 700 foundations. That's a lot. Why so many?
Yeah, I mean, this is super important because if you think about 700 plus foundations, things like Linux Foundation, things like Cloud Native Computing Foundation, where all of the latest and the greatest projects are happening. Things like OpenSSF, which is about Open Source Security Foundation. Things like PyTorch Foundation, LFAI and Data Foundation, which we just joined recently. All of these foundations is where latest bleeding edge work happens in the technical aspect, and of course, driving the community and the industry forward together. So those are the elements why Intel has always been part of it, and truly brings back that chop wood, carry water essence that is essential for keeping that open source ecosystem thriving.
Well, and I expect we'll likely hear about a lot of these during Greg's keynote today.
Absolutely.
Yeah. Okay, so you've been, let's turn to you for a minute, because you are an inspiring leader here at Intel. So many people follow you and love you. What is your advice for the next generation of developers who want to be in a leadership position like you?
I think the things that I'm excited for innovation today, for example, let's talk about that for a second, then I'll give the advice.
Okay.
The first is, I'm super excited that our 4th gen Xeon is now available in the major cloud providers. So try that out. Amazon, Microsoft, Google, wherever it is, try that out, pick up the latest upstream software. The performance boosts are just unimaginable, so try that out. Second is, Pat talked about Intel Developer Cloud. If you want to try out the latest hardware, try that out. That is super important. Now, the advice really I would like to give you folks, for the latest new set of developers is essentially think about how you could be mindful. This kind of goes back to our keynote from yesterday. Think about there are certain things that you could be really, really effective at, and how you could be mindful and really be very successful in that one element. And then once you are successful in that, then again expand your horizon. So really, the fundamental advice is get very comfortable with being uncomfortable.
Right.
Because the technology landscape is always changing.
Yeah.
So get comfortable and unlearn and relearn.
And be kind to yourself, right?
Be kind to yourself.
Yeah.
Because as we were talking earlier, we often are our biggest critique of ourselves. And as Dan Harris said yesterday, is that when you are critiquing yourself, think about it. Is that the advice that you'll give to your dear friend?
Right.
If not, let's be kind, feel connected to the larger humanity, the community around you, and see how it could be more impactful.
That's right, and what a great way to start the day. So thank you, Arun, for that pep talk. We really appreciate it.
Thank you.
And we're going to move now from open source to open ecosystems. Tony gives us a look at how Intel helps startups help themselves. Let's take a look.
Pat talked earlier about Intel Ignite, but Intel actually has a lot of disruptor programs. We have AI disruptors, we have Intel Capital, and we have the Intel Liftoff for Startups program. And I'm joined right now by Raul Nair, who is one of the engineering leads of the Intel Liftoff for Startups program. So Raul, can you tell us a little bit about Intel Liftoff for Startups?
Yeah, of course. So Intel Liftoff for Startups is an early stage startup accelerator program. It's global, it's free. We help startups with hardware, how to scale. Essentially, it's a partner-driven program. So when they bring in with their idea, based on what they want, we tend to act like a conduit to the entire Intel. Whatever engineering support they need, like I said, hardware, cloud credits, all those things are provided. Along with VC support, all those things are provided through Intel Liftoff.
Okay, so Intel Capital provides basically investment and support, and same Intel Ignite does business support, and you guys sounds like you're doing engineering support.
We are doing engineering support similar to our sister program for Ignite, where they mostly focus on the business aspect of it. We are strongly engineering driven, and if you have an idea, you come with us. We have a dedicated session with you, figure out where we can work together, optimize your solution. Sometimes it could be scaling to the cloud. Sometimes it could be, okay, maybe I want to run these things on a CPU or these things on a GPU. All those things are worked out, and our engineers work with you to design the product and get your first revenue.
So what types of technology are the people that you're working with use? Like what types of software and then what types of hardware?
So in the last 1.5 years, it's mostly been AI. So Intel Liftoff works with many different aspects of technology. It's HPC, AI, media, and all those things. But the startups that we are seeing these days are AI, generative AI, and things like that. As you can see, some of our members are already here, SiteMana and Prediction Guard. All those folks are working on LLMs, and we help them run LLMs really fast on Intel hardware. Some of them have been deployed on IDC and doing very well.
All right, well, that's fantastic. Thanks you for joining us, Raul.
Thank you, Tony.
And as you can see, we are driving innovation forward through engineering support, investment, and a lot of focus on building the right technologies that developers need to be successful.
Welcome back. I'm joined with Hillary Littleton, who is the head of marketing for FitMatch. They've been getting a lot of attention this week. Hillary, so first question for you. How is FitMatch revolutionizing the fashion industry, and what kind of response are you seeing from retailers?
Yeah, absolutely. So we've developed a innovative, personalized, but totally private shopping experience for the consumer. So during a scan, we actually derive a customer's 3D shape with our patented methodology and actually match them back to a digital twin. Somebody in our database that's already tried on the product that has the most similar shape to them. So the data that we can serve back up to the consumer is completely unique in that way. So they not only get to see their own shape profile, but they also get to see customized product matches and recommended sizes that are guaranteed to fit their shape. And then on the retailer side, we've really seen this shape shift their business, no pun intended. We've seen lower return rates, higher conversion, long-term loyalty is increased, but I think where the biggest driver for FitMatch can be is helping with inventory management. There's a lot of excess inventory that is not efficiently managed. So if FitMatch can come in, help provide the data that brands can then target customers in those specific size ranges that they need to get rid of, we could see that as a huge opportunity for us to come in.
Absolutely. Well, I think about how much I order online and return because it just didn't fit. So
exactly.
I'm excited to use this. So let's talk about AI. What role does AI play in your technology, and how is Intel helping you scale?
Definitely. So AI is really part of our DNA at FitMatch. It gives us the ability to derive that 3D shape, and then combined with Intel's RealSense LiDAR technology, we're serving up an experience you really can't get anywhere else.
Absolutely. Well, I was watching Pat doing it earlier before his keynote, and this data feels pretty personal. So 2 questions for you. How are you protecting that personal data quickly, and what's next for FitMatch?
Yeah, definitely. So it is very personal, but we have safeguarded user data with the best-in-class security measures. So we don't use the camera. Like I said, we use the LiDAR sensors. So that means no photos are taken, no videos are taken, no bio-identifiers are taken. So all that's used for processing is what you just saw, that anonymized point cloud avatar.
Awesome. Well, thank you so much for being with me here today. We really appreciate you. And by the way, don't go anywhere. We'll be right back in a minute with a lot more to come.
No computer works without a chip, and no chip works without a substrate. This thin layer right here that holds the chip in place so it can communicate electronically with the motherboard. Intel is leading the industry with the next generation of substrates made of glass. Today's computers are increasingly using multiple chips on one substrate. As these substrates take on more silicon, our current organic substrates, mostly plastic, can warp. Glass is more rigid and can handle more chips on a package. Glass substrates can enable more efficient power delivery solutions and higher speed signaling. They can seamlessly integrate optical interconnects that require less power and move data more efficiently than today's copper interconnects. Glass substrates will help advance Moore's Law. Glass enables 50% more die content on the same package size than organic substrates, which is very crucial for AI and data center products. Intel plans to deliver complete glass substrate solutions later this decade.
Welcome back. Let's get back out to Tony on the floor. Tony, who are you talking with right now?
Well, you never know who you're going to run to at Intel Innovation, and I'm here with David Cantor, who's the founder and executive director of ML Commons. So David, can you tell us a little bit about what ML Commons does?
Sure. ML Commons is an open engineering organization focused on working collaboratively to make machine learning better for everyone through data and benchmarks like MLPerf.
Okay. And MLPerf, how does that help all of your constituents, all the people that you work with?
Yeah, so our organization represents academics, industry, customers, sellers, and part of the point of benchmarks is it helps us to define what it is for AI to be better. How do we make it faster and give everyone the confidence to know what they're getting as a buyer, to know what they're designing for the next generation, and it helps us gauge the overall progress of the industry, which has been, amazing, as you know.
Yeah, absolutely. It's been very hectic and very fast. I was at Habana when we built the first data center to submit to MLPerf. And let me tell you, it was a very complex, hard process. I'm sure you have some insight there. What do you think the challenges are of actually doing something like that, submitting to MLPerf?
Yeah, so, Habana was one of only 3 teams that submitted to MLPerf training for the GPT-3 175 billion large language model. So like super representative of the emerging generative AI. And it's a benchmark that really tests every aspect of your systems, from the hardware to the software to the people putting the data center together to the cooling, and everything needs to come together seamlessly to just get to the finish line, period. And so, it's something that gives people tremendous confidence.
All right, and given that challenge, if I'm a company, why would I go through that hassle to submit a benchmark like that?
First of all, you're going to learn along the way. I'm sure you did. Yes. But the other thing is it gives your customers the confidence to know, hey, things are just going to work. This is a solution that we can count on, and that's super important.
All right. Thanks, David. Back to you, Madeline.
Thanks, Tony. Moving from one neighborhood of the open community to another, I have with me Kelsey Hightower, software engineer, developer, and advocate. Kelsey, thanks for being here.
Happy to be here. I'm super curious about what's the state of things, so I'm looking forward to this one.
Yeah, I love when you sat down in the chair, you said you're curious, and that means you're open to new possibilities as opposed to excited, which means you already know what to expect.
Exactly. All this stuff that's happening at the hardware level, as a software person, we tend to ignore that stuff.
Yeah.
But it sounds like we're in a whole new era where accelerators are all the rage, and I'm coming here to learn.
Yeah, we're in our AI era now, as I said yesterday. So one of the benefits of being here in person is that our attendees get to hear these incredible luminary speakers like yourself. Is there anything you can tease with our online audience who won't be here later today?
Yeah, I think I'm recapping a little bit over my career and how things have evolved, things in the cloud. Now machine learning has all the rave, and where are we at? And so in my Luminary keynote, I really just want to talk about my career progression and how technology played a role the whole way through. So if you've heard me talk about technology, you heard me talk about the cloud, now I get to talk about myself.
That's awesome. Well, you've spent a lot of time in your career on Kubernetes, and recently you said that it needs to go away, and when it does, that'll be a sign of progress, which seems a bit counterintuitive to most of us. So what does that mean, and what's going to replace it?
Well, typically things that are super successful, they disappear. They're no longer a problem, like our freeways. Most people, when you set out to drive, you don't think about the freeway and whether it's going to work or not.
Right.
You just plan your route and you know the infrastructure is going to be there. Kubernetes is infrastructure. And today we talk about it a lot because, number one, it isn't finished. There's lots of gaps in between what it is and what we want it to be. And once it starts to fade away, it will feel like it's gone. And it will just be there, super stable.
So it'll be there, it won't be completely removed.
And the thing I think replaces it is the things that we want to do, right? So the gap, there's that saying, easy to predict the future when you're working on it.
Ooh,
and the things that people are working on are like a much easier way to express ourselves. I would like this app to run across the globe and not have to think about the layers underneath. And that's what people are working towards. Some people think about that as serverless, platform as a service, but that's where we have to go. And once we go there, it will be a world where we don't mention Kubernetes anymore, and that will be the success criteria.
I like that. So what are you listening for today in Greg's keynote?
Look, a lot of people have experienced some Intel CPU in their life. It allowed them to do something. So for me in my career, my early days in cloud computing, I remember when Intel introduced VTX extensions. And that's the thing that lets you do virtual machines at an accelerated rate. And for some people, if you had like a Windows PC but you wanted to run Linux on it, having Intel CPU allow that to be fast, was a game changer. And if I think back to my earlier years when I was burning DVDs or burning CDs, well, a lot of people may not remember when Intel added that hardware accelerator, it went from 24 hours to burn a CD to minutes to burn a CD.
You're right.
And that hidden capability inside the chip. So what I'm listening for is what's the next thing that Intel is going to democratize? Right, there are things that are available at the high end, super expensive, can't get one, but then we eventually bring it to the desktop where everyone has it. So I'm listening now for what's the next thing I can do on my personal machine.
I love it. Well, thank you, Kelsey. Thank you for being here and taking the time. Break a leg at your Luminary later today.
Awesome.
I can't wait to listen to it. Tony, let's get back to you. I've been waiting for this one. You're at the Modern Studio Experience with my bestie, Craig.
That's right. I am here with Madeline's bestie, Craig Raymond, in front of actually Intel headquarters.
Here we are, just live from the Intel headquarters. You guys can all see. Oh, actually, well, we'll just pull the curtain down from this one, but we're actually not here at our headquarters. We're actually in San Jose, and we're here at Innovation Floor, showing off some of our latest virtual production technologies. So as you can see, all in complete reality capture. This is real that we've gone through and used telegrammetry to go ahead and put together an amazing reality type experience. But we've also been doing wonderful game worlds and all of the other virtual production and creation tools with AI in our modern studio for developing here. So, let's go ahead and back this up. You can see we're actually doing complete virtual camera tracking. So as we can go ahead and move around virtually, this is something that we're able to do now, especially with AI and the power of our Xeon workstations. We can do it at a fraction of the cost with a full broadcast production level. So, I mean, pretty cool, Tony. We can be anywhere that we want. And so that's really what we're showing on the floor here in this modern developing studio is now we have an amazing backdrop and all this amazing technology for all you creators out there. So, you should come on down and take a look at these. Yeah, pretty cool.
Yeah, this is really cool. Gigantic screen, which is obviously cool by itself, but then all of the AI stuff behind it is really fantastic. And let's go over here. You've got something else you want to show us, right?
Oh, we've got a bunch of goodies in here. So let's go ahead and take a look at the next. And so right that we have over here is we're showing how our avatars are working into another tool in our virtual production bag. And here we're showing two technologies, one of them being MetaHumans. As you can see here, it's actually creating virtual avatars that you're actually tracking with AI. This is a plugin that would go in Unreal 5, and I can go ahead and bring all of our avatars to life with whether they're speaking, showing emotion, and it really allows them to carry that on. And really now we can realize the reality by capturing an actual human's face. And so, Tony, if I go ahead and take a couple of quick pictures of you, then in-world AI is an additional SDK that then takes all of that great emotion and movement in our cartoon avatars and makes them into actual humans with that full fidelity that we see amazingly in today's video games, and can't wait to take them into short form cartoon and animation work. So here we have just another example, and this is running on our Raptor Lake refresh that we have here. So showing for the first time some of our brand new hardware that is pre-launch, so we're giving everyone a first peek on what that really looks like. Oh, pretty cool stuff.
Yeah, that is really amazing stuff. And the other thing we won't have time to show you actually is we've got Thunderbolt 5 shown over here. So if you want to see the first Thunderbolt 5 enabled laptop, it is right over here. You're going to need bandwidth for all of this AI stuff. And back to you, Madeline.
Thank you, Tony. We are just minutes away from Greg's keynote, and the audience is filing in. Don't go anywhere. We'll be right back.
Back in 2017, the major problem was they were facing crop failures of unidentified pest attack. Pests, they do have thermal traces. We can detect them through thermal imaging and other things. There are some heat traces that gets formed due to some specific hormones in the leaf plants itself. And there I combine the technology and the biological side of it. In OpenVino, we integrated Kishano for de-blurring the images taken from satellites, and I came up with a solution that would detect both plant diseases along with pests in a very limited amount of time.
I remember when I got to know about the Kishano project. It truly exemplifies how students can innovate using artificial intelligence and build solutions which not only impact them, but their community at large.
Welcome back. Intel innovation is for developers. And when you get developers together, there's nothing more fun than a hackathon. Tony did a quick peek into the hackathon in the Innovation Clubhouse. Let's take a look.
We're here in the Innovation Clubhouse, and I'm joined by Eduardo Alvarez, who's our AI solutions engineer. He's actually running the hackathon that we've got going this week, and we wanted you guys to see what's going on. So Eduardo, tell us a little bit about the hackathon.
Yeah, so the hackathon that we're hosting today is called the AI Innovation Bridge. And essentially what we're trying to do is bridge people from ideas all the way to actual solutions that they can build post-innovation. Yeah, so that's it's comprised of really engaging hands-on with mentors and the different tools we have in the Intel Developer Cloud in order to help people essentially learn how to fish and be able to be successful like after innovation, not just today, but into the future. Yeah.
Okay. And in the Developer Cloud, what types of software are they using? I mean, obviously we've got our hardware in the Developer Cloud. I guess let's ask both. What software are they using from Intel? What hardware are they using?
Yeah, so they're focusing around using a lot of our integrations that we have, like with Hugging Face, for example. So like with the Habana, Optimum Habana, which allows us to run a lot of the models that are on Hugging Face directly on Gaudi 2 processors. Well, a lot of people are off hacking on that. We have other folks using like Intel's extension for PyTorch, running it on our data center GPUs, as well as like a plethora of different software packages and tools on our Intel fourth generation Xeon platform. Yeah.
Okay, so they're using everything. I mean, basically the hackathon is just whatever solution you want, just have at it.
Yeah, and actually one of the cool things we're actually doing is we have one track that is dedicated to a low-code solution for building, fine-tuning large language models, and that's in collaboration with a developer preview we have going on right now. It's called Large Language Models in the Fast Lane, so it's a really cool little thing we're doing as well. Yeah.
Okay.
Yeah.
That's really exciting. And then is there one winner? You said mentioned tracks. Is there multiple tracks? How many winners do we have?
So we have a generative AI startup track, which is actually run and led by our Liftoff program. They're actually launching at Innovation. It's a really cool, kind of like an incubator, kind of very high touch program with startups. And then we have another track that's called Open Enterprise AI. So that's really anything and everything people want to do with AI across the platforms that we have available on Intel Developer Cloud. And then lastly, we have, like I mentioned, the LLMs in the fast lane. And that one's using that low-code solution to fine-tune and perform inference with some really cool, like, large language models, yeah.
Awesome. Well, thanks for telling us about the hackathon. And I mean, you look around, I'm sure there's a lot of development going on with the play area that we've got here. I hope you guys enjoy it, and I hope you guys learn a little bit about LLMs in the Developer Cloud.
Tony, I bet you were in heaven yesterday. That was your happy place. It's amazing what those young developers and engineers are doing.
Yeah, absolutely. I really love seeing everything that they're building, all the work they're doing. It's really impressive.
Okay, so the keynote's about to start. What are you looking forward to this morning?
Well, I think, as we mentioned, Greg's going to probably do a deeper dive into some of the software that we're supporting. Obviously, AI frameworks, how we work with PyTorch, TensorFlow. As that industry changes, that core AI functionality updates, we got to move with it, so we're going to do that. I'm sure he's going to talk about that. He's going to talk about open ecosystems and software, how we work with the community to build bridges, build solutions that developers can depend on. And I'm sure he's going to talk about confidential computing, security. As he mentioned yesterday in his post-keynote talk with us, he said, AI and confidential computing go together. You want AI? That's great, but I need it to be secure as well. So I think he'll talk about kind of all of these things.
Tony, that's a pretty long list.
Well, it's Greg Lavender. Greg Lavender is going to talk all the technical things that he wants, and it's going to be a lot.
I know. I mean, he did say on set yesterday, he's got a lot to pack into 60 minutes, and it's tough to rein Greg Lavender in.
Yeah, and fortunately, that is not my job. I report to Greg Lavender, so if Greg wants to take all the time he wants to tell us about the awesome technology that he's working on, he should have at it.
That's right. He's the boss. Tony, we talked a lot yesterday about the energy in the room. People filing in, how excited they were. What kind of energy are you feeling out on the floor today after all of the momentum of day one?
Well, I think everybody's pretty fired up. I think yesterday people were coming in and obviously people didn't know what to expect. They hadn't seen the showroom floor yet. They hadn't seen any of the demos. But then once Pat got done, they were able to go see all the demos of what Pat had been talking about on stage, see kind of the modern studio experience that we showed, the generative AI booth that we showed yesterday, all of the things that we've highlighted in our broadcast. He was able, everybody was able to see all of that on the floor, and I think that kind of lifted everybody up and got everybody excited about what Intel's bringing to the table.
Absolutely, completely agree. Glad to see everybody here. But y'all, it's that time. Greg is about to take the stage. Don't go anywhere because after the keynote, we'll be here with exclusive interviews and more from the showcase. Enjoy the show, everybody.
The keynote is about to begin. Please take your seats and silence your cell phones. Thank you.
Everybody's dancing in the moonlight, dancing in the moonlight. Everybody's feeling warm and bright. It's such a fine natural sight. Everybody's dancing.
How do we know when innovation starts? Does it start when the world's greatest minds ponder the greatest challenges? Or is it part of something larger? At Intel, we believe innovation, deep technical innovation, starts by enabling developers to create through hackathons, workshops, and early access to hardware and software. It starts with a new and disruptive point of view, from individual entrepreneurs and academics, to disruptive thinking from startup companies, to internal technologists and external customers and partners, engaging as early adopters, collaborators, and fearless innovators. Innovation is about helping you, the developer, advance new technologies, from future advanced research and projects to the here and now.
Welcome to the launch of Intel's 4th generation Xeon processor and our Max family.
From hardware roadmap development across CPUs and accelerators, and speeding advancements in critical workloads, such as AI and trust and security. Innovation is helping developers focus on, well, development.
Intel is committed to the success of the open source community.
Innovation is working together to accelerate an open community to help drive scale. Through collaboration, contributions, and engagement with the community at events. And evolving to the new challenges of today and helping to make the world a better place. At Intel, we believe that this sort of deep technical innovation starts with all of those things. And most importantly, we believe innovation starts with you, the developer. The one thing we can all be sure of, there is no end to the innovation that can be achieved with us together.
Please welcome Intel's Chief Technology Officer, Greg Lavender.
Welcome to day 2 of Intel Innovation. Today, I get to be the Chief Talking Officer and share with you just a sample of some of the deep technical innovations we are working on to enable you now and into the future. That was such a cool video, don't you think? The fun fact is these select snapshots represent moments of us partnering with you just in the past 12 months alone since Innovation 2022. This developer community is the catalyst for driving the transformation and deep technical innovations that we're doing to create fundamental change across industries with Intel hardware and software. As Pat has said, software-defined, silicon-enhanced, I will add silicon-accelerated. There's no other field seeing such rapid and deep technical innovation as the field of artificial intelligence right now, especially around generative AI and large language models, as we all keep hearing. Yesterday, we heard Pat's vision to bring AI everywhere. I like to think of this as us leveling the playing field for all of you, helping to reduce complexity, building on AI solutions, delivering productivity and choice of programming models, and enabling you to balance performance, cost, and capability. Today, I'm excited to show you how we're going to bring AI everywhere, preparing the industry for the convergence of AI and security, which I'll talk about in a minute. The key to leveling the playing field across all AI developers is a strategy that's built on open systems and open ecosystems. For Intel, we achieve this in the following ways. First, we contribute to and enable open AI ecosystems to help you accelerate performance of your applications on Intel platforms. without having to rewrite your code all the time. We continually deliver code contributions and optimizations into multiple upstream and popular AI and ML tools and frameworks, such as PyTorch and many other open source frameworks popular with AI developers today. This ensures that these frameworks are optimized to deliver the best performance on Intel platforms and enhance your productivity and enable programmability for all Intel developers. Let us look at PyTorch specifically since it's so popular and widely used. Intel has been an active contributor to PyTorch since 2018. We are currently one of the top 3 contributors to the PyTorch ecosystem with a 3x increase in the number of changes submitted to the source code from 2021 to the end of 2022 and throughout this year. We have had 4 Intel software engineers, top engineers in our company, as dedicated PyTorch maintainers to help address issues, review pull requests, and contribute to PyTorch's ongoing innovation and development. And PyTorch 2.0, released earlier this year, leveraged the Intel OneAPI Deep Neural Network library, which we call OneDNN, including optimizations for the A10 operators, the PyTorch library where tensor applications are defined and accelerated, and support for bfloat 16 and other auto mix precisions. As well as contributing to the PyTorch core code base, we are actively engaged with the PyTorch developer community through GitHub, training workshops, and our own Intel extensions for PyTorch framework, which allows us to contribute our code into the bottom of the PyTorch stack. Intel was recently selected as a premier member and earned a seat on the respected governing boards of both the PyTorch Foundation and the AI and Data Umbrella Foundation, all within the Linux Foundation. This is a testament to our level of commitment of resources to AI developers. Bottom line, millions of developers can achieve the best performance for AI solutions running on Intel, knowing that Intel optimizations are pervasive throughout the ecosystems, including the downloads of PyTorch by default. We hear from developers all the time that you seek neutral, direct programmability, code portability across hardware devices, and an alternative to a proprietary model, so that you can avoid vendor lock-in and program across multi-vendor, multi-architecture environments. I've spent my life doing that. With 48% of developers targeting heterogeneous systems that use more than one kind of processor, portability and efficient multi-architecture programming is required to address the increasing scope and the scale of these real-world workloads. We are enabling choice of hardware for you to meet your training and inferencing needs across the ever-diversifying set of workloads and applications, and one that delivers an open, accelerated computing ecosystem. Intel continues to invest in our OneAPI and accelerator programming using the SYCL, Data Parallel, C++ programming language extensions from the Kronos group. The industry benefits from an open, standardized programming language for programming accelerator hardware that everyone can contribute to and collaborate on without vendor lock-in, and one that can evolve organically based on its community and the public requirements for it. OneAPI has seen a rapid increase of 85% in its installed base since 2021, and new features are being added regularly. Arguably, one of the most exciting enhancements has been CodePlay's official release and updates of a multi-platform plugins in OneAPI for NVIDIA GPUs, OneAPI for AMD GPUs, and of course, OneAPI for Intel GPUs. And the code will work seamlessly across Intel, NVIDIA, and AMD platforms if you commit to that level of portability. Using the OneAPI for NVIDIA GPU plugin, you can now run SYCL code on NVIDIA GPUs. This is a major milestone for the OneAPI ecosystem and the developer community, creating a viable migration path from CUDA and other proprietary programming models to SYCL and OneAPI, enabling AI programming everywhere. The download for the latest toolkits, scan these QR codes, and today start using these new OneAPI plugins yourself. And we look forward to getting your feedback, and we will continue to enhance and develop this together with CodePlay. With the increasing rate of AI's adoption, OneAPI is enabling AI everywhere, particularly with startup ventures, and you've seen some of those. The Intel Liftoff program targets early-stage AI startups with technical expertise from our Intel software engineers, helping them create and deploy AI solutions with great performance. Yesterday at Pat's keynote, he featured 3 of the Liftoff startups, Antares, DeepRender, and Scala Biodesign, all of them using our latest hardware and AI software, and they developed an Intel Developer Cloud. The 100 Intel Liftoff program members represented here have been focusing on developing LLM-based generative AI solutions and applications. During a recent 5-day AI hackathon, the Intel Liftoff program startups achieved a significant milestone by fine-tuning LLMs with the LoRa, low-rank adaptation of large language models, for the first time on Intel Data Center GPU Max series processors in the Intel Developer Cloud. Check out the Liftoff Startup Program demos on site back here. I looked at them yesterday, and participate in the AI Innovation Bridge hackathon if you have not already done so. And if you are a startup, consider applying to the Intel Liftoff program today using the QR code that we see here on the screen. The CUDA ecosystem is being disrupted due to the generative AI revolution and the importance of higher-level programming abstractions using frameworks such as OpenAI's Triton, Google's JAX, Modular AI's Mojo, and Julia for scientific computational computing. And more is coming. The rapid rate of innovation of AI technologies is creating new disruptions to the status quo and freeing the developer from proprietary lock-in. This is important for the future of everyone and to get AI adopted everywhere. Intel's open ecosystem approach is to level the playing field and support the adoption of programming models and tools such as MLIR to accelerate and enable AI developers to write once and run on any accelerated hardware. We are elevating the level of programming abstraction to avoid proprietary vendor lock-in and give you more choice and give you trust. To achieve our vision for an open AI accelerated ecosystem, it takes an industry leaders to come together. Yesterday at the Open Source Summit in Europe, the Linux Foundation announced the formation of the Unified Accelerated Foundation, or UXL, to promote cross-platform development to enhance performance, productivity across any architecture. Intel, along with the other industry leaders that you see here, have joined this foundation to support this initiative, and we expect more to join in the future because this is so important. UXL will be managed as a joint development project under the Linux Foundation. It will unify around open standards, starting with the One API specification. This takes our One API vision and tools where we intended all along, an open ecosystem of accelerated computing projects built on open standards. From a data perspective, the AI data flow is comprised of a vast and complex set of workloads and multimodal data sets. There is no one size that fits all when it comes to AI compute requirements. Developers want productivity, you want consistency, we want quality, and we want best-in-class performance for both scale-up and scale-out computing. As Pat showed, Intel can deliver the AI platforms and software across the continuum of AI workloads, from the client and edge to the enterprise data center and to the cloud. Just last week, the ML Commons published results of its latest MLPerf Inference 3.1 performance benchmark for GPT-J, the 6 billion parameter large language model. Intel submitted seven inference benchmarks, including GPT-J on 4th gen Intel Xeon Scalable processors. These results show great performance for general purpose AI workloads, including vision, language processing, speech, audio, translation models, and much larger DLRM version 2. Intel remains the only vendor to submit public CPU results with industry standard deep learning ecosystem software. So now I want to talk a little bit about how we will continue to innovate our Xeon roadmap to meet the diverse AI workload needs, and we'll introduce our 5th gen Intel Scalable processor codenamed Emerald Rapids on December 14th, as Pat mentioned. We already see great performance and improved power efficiency with this new processor. And I'll show you again, if you weren't here yesterday, the one that Pat showed. This is the new Emerald Rapids package and SoC. And that'll be available in December. And we have already distributed quality samples of Emerald Rapids to our customers for final hardware, silicon, and software validation. And I'm personally excited about Pat's announcement of Sierra Forest and Granite Rapids, both of which are scheduled to launch in 2024. I'm going to ask David from our demo team to come on stage with me so we can show you what Granite Rapids can deliver today with early chip samples.
Definitely.
David.
So we have that future gen Intel Xeon codename Granite Rapids, and we're running it on the Birchstream platform. And this is going to support up to 12 channels of memory. And along with the multiplexer combined rank DIMMs, we're going to deliver 8,800 mega transfers per second. Let that sink in, right? That's
huge.
That's a lot of transfers. So it's going to be industry leading. So let's take a quick look at it. Here up on the screen, we're actually connected back to our labs. It's running on a system with early silicon. As you can see here, the memory throughput. This combination delivers a 2.6x increase in memory bandwidth, and this is for the most throughput-hungry workloads you have. So with that, we could use that memory throughput along with built-in acceleration with AMX, delivers the 2 to 3 times increase in AI workloads. That performance means that you can concurrently run multiple larger models on a Xeon CPU. And let's see, right here, we're actually showing 6 inferencing models that are running at the same time. So Xeon is and will deliver the performance you require to support your fine-tuning and specialized LLM needs. Back to you, Greg.
Thanks, David. Hang out here on stage with me for a little bit. We've got a few more things to show you. This is what I love the most about working at Intel is the deep tech that we do and the engineering that all our teams do, both hardware, software, to be able to produce early silicon like this, well before it ships into the commercial market. So a list of all the demos you will see today and various web links that I will point to can be found in your Innovation Event app alongside this keynote. The growing complexity and size of AI models, such as in large language models, has increased demand for discrete accelerators, especially for inference. So I'm going to walk back over here to David, and I'm going to say, David, we've talked a lot about our Gaudi 2 AI accelerators, and I'm going to show something that we've done recently. So hold one up. This is actually the card that actually has the Gaudi 2 AI accelerators in it. We package these up in a module, and we tend to put 8 of them in a single chassis, and that gives us essentially a cluster level building block to build much larger scale clusters. So David, let's take a look at an example of Gaudi 2 in action.
Exactly. I'm actually going to use one of our customers' stories, and it's Prediction Guard. They actually offer APIs that check for factuality and toxicity, which is very important for things like medical transcriptions. And you really want to prevent false and maybe even potentially harmful information from getting through. Here's on the screen, you'll see one example of a sample transcription from a patient visit. And we can ask it the question, what symptoms is the patient experiencing? So as it's doing that, it's actually going through and checking through multiple LLMs, verifying that data to make sure it is factual and not toxic. So this is just one transcription that's happening, but the healthcare customers, they want to be able to several thousands of them per day. And they want to do it as fast as they can. But with Prediction Guard, they actually are running NVIDIA A100s. And unfortunately, it wasn't quite meeting their customer needs. So they had to look for an alternative. So with that, we had them try out Intel Gaudi 2. And straight out of the box, they were able to bring up their solution in just a matter of hours. And they experienced a 2x speed up for some of their most important models. They have since moved their production API across to Gaudi 2 and running that into the Intel Developer Cloud. And that's where they're going to productize their services for the customers.
That's really great. And we have the Gaudi 2s deployed in Intel Developer Cloud, so you can gain access. Get in line, because a lot of people are queuing up for the capabilities we have. We'll be continuing to add a lot more compute to drive the scale as much as we can satisfy the demand. So the compute needs at the convergence of AI and HPC are met through Intel Xeon CPU Max series and Data Center GPU Max series, both of which are delivering groundbreaking performance gains as you've seen. Argonne National Laboratories, in partnership with us, is building their AI Aurora supercomputer. It's equipped with 63,744 Max series GPUs today. That's a lot of computing power. And they're pushing toward training trillion parameter scientific models. This is the largest deployment of our Max GPU, the biggest Max CPU-based systems, and the largest GPU cluster in the world. Here's an example of our GPU Max package, the one that we deploy. And these are, again, available in Intel Developer Cloud. This is for a wide range of workloads for scientific research in fields like biochemistry, energy, and astrophysics. The GPU Max 1550 has demonstrated an average speedup of 30% over an NVIDIA H100 for those workloads. And David has another demo for us to see it in action.
Ed. Oh, that's for me? Oh, no. It's, so we're actually going to have, actually, you did mention OpenAI's Triton earlier, so we're going to take an example of that. And it's a programming language and compiler, but to perform deep learning operations on the GPU, we're going to try to do that on the Max series GPU. You really should try to compile and run any LLM with using Triton in the backend. With PyTorch 2.0, this is easy to do, and all it's going to take is one line of code to do that. Here I have a sample code. As you can see here, it's a sentence completion workload written in PyTorch. It's an inferencing example. It's natural language processing. And I've compiled it, as you can see out there on the right. And what you also would mention that we're going to point out is here is that one line of code that was used. Insert that in. The compiler takes over. And then what it does is it generates the optimized kernels that's needed to be running Triton. So it's that quick and easy. And you know what? This really delivers that developer productivity that you referenced earlier. And this helps HPC and AI developers really build their AI solutions across a cluster of Max series GPUs.
And it's available in Intel Developer Cloud.
Yes, exactly.
Yeah, thank you. So thanks, David. Don't go too far because we got another demo in a little bit. At the edge in the client, Intel's driving deep collaboration across the breadth of the Linux Edge and Microsoft PC ecosystem so that you get the best platform performance regardless of your preferred tools and frameworks and underlying hardware. But of course, we recommend OpenVINO in addition to yesterday's spotlight about the latest optimizations in OpenVINO, powered by Intel One API. We're enabling developers optimizing standard PyTorch and Onyx, the Open Neural Network Exchange models, to deliver compelling runtime AI performance, both for inference and efficiency of your applications, particularly in those edge and client sort of use cases, and Pat went in detail about that yesterday. So Intel and Microsoft continue to collaborate all the time. We do a lot of co-engineering together for Windows, of course, for all of our platforms, both client and servers. And these optimizations in the Windows Onyx runtime are, again, jointly done between Intel and Microsoft. And we recently added the new Intel AMX extensions into the default execution provider for the Onyx runtime and running on Intel CPUs. This resulted in 4x to 5x improvement in the basic matrix multiplication operations performance compared with the previous Intel third generation platform. So Intel is really driving this horizontal approach to AI development and deployment by developers by closely collaborating with all of our ecosystem partners and developing edge native solutions like Project Strata that you heard about coming early next year. For the client, Pat said it very clearly. AI will fundamentally transform, reshape, and restructure the PC experience for everyone. And I'm excited to see our AI PC vision come to life, starting with the upcoming Intel Core Ultra processors, AKA Meteor Lake, with an impressive neural processing unit, NPU, providing an integrated AI engine for local inference. From a software development perspective, which is where I spend most of my time, we are making sure that when you bring web applications to our PC platform, that they run seamlessly. We are delivering the power of our entire hardware platform to the web through the standardization of new web APIs like WebGPU, and soon with the web neural network, WebNN, along with the WebAssembly for running native code on the CPU. We continue to closely work together with Microsoft to enhance the AI experiences across the board. As you can see from this quote, we are expanding the native client AI story by integrating CPU, GPU, and NPU acceleration across DirectXML, as well as the Windows Studio effects, and of course, our own OpenVINO technology. This general programmability allows you to take advantage of all of our hardware acceleration in the native Windows frameworks out of the box and provides a scalable ecosystem on which you can build on the Meteor Lake platform in the most energy efficient way. At the PC application level, we continue to support a broad and deep PC application ecosystem by collaborating with over 100 of the top global OEMs and ISVs, enabling the most popular applications across collaboration tools, video, content creation, and gaming. More to come as this technology comes into the mainstream, as you saw yesterday. Across the edge, the client, the data center, the cloud, we are working to meet your AI development needs everywhere and within an open accelerated computing environment, as I've already said. The broad portfolio of Intel's latest and greatest accelerated hardware and software to meet your varying AI needs is available today in the Intel Developer Cloud and has reached general availability officially in this announcement. We are building out capacity as fast as possible. Pat kicks me in the seat of the pants every day to go faster, so I want you to register and join the queue now as we build out more capacity and make it available to everyone. Early access to our portfolio drives the scale of AI deployments and lowers the barrier of entry for you. This is particularly important for enabling you to harness the full potential of LLMs, which remains a roadblock to bring things into production. And we have lots of companies, I can't name them all, already doing this at scale on our platforms, the Gaudi, working with our Xeons to do all the data preparation and the inference, and of course our Max GPUs. So, since the beta announcement last year, we've been building out capacity and growing the Intel Developer Cloud offerings, and we have made a lot of progress. So as I said, Intel Gaudi 2 accelerators are available, spanning thousands of AI accelerator cards, and hundreds of systems and clusters are specialized for large-scale AI training, but you can start with just one, okay, and scale up as you get to need those additional computational capabilities. And you can do some fine-tuning and then go deploy your inferencing models on our Xeons. We have finalized the build-out of hundreds of Max series GPU cards, deploying on our Gen 4, 4th Gen Xeon host systems, with more coming every day as fast as we can enable them. So lots of good hardware, lots of good software. Bring your workloads, bring your programming experience, give us feedback, and help us drive this as a competitive offering in the market to give customers choice, better economics, and better power efficiency. So we're further expanding our GPU portfolio, making thousands of these GPUs available to developers with ready-to-use one API, software stacks, Intel-optimized AI frameworks, and LLM models. And when you land in the Intel Developer Cloud, there's an entire ML ops environment there for you to use to make you very, very productive. And we can use Jupyter notebooks to package things up to deliver common application packages for you. As we prepare for the Emerald Rapids launch, which we talked about, we'll have it available for preview in Intel Developer Cloud prior to its launch. So if you want to be on the leading edge of that and preparing yourselves to jump to Granite Rapids next year, you could come in and start doing that and benchmarking it. Please feel free to give us feedback. We'll help you with performance tuning. We'll help you with tweaking the software libraries to basically give you the best performance at the best power efficiency. So with this expanding portfolio of platforms and Intel accelerators, we are onboarding a growing number of developers using the Intel Developer Cloud. So let me walk over to the pedestal here, and Dave is going to rejoin me and give me an example of Intel Developer Cloud.
Definitely. I'm back again, folks. And I have two examples for you. There's actually two companies I'm going to cover here. One is called BWant, and they specialize in multimodal AI platforms and data management for enterprises. And Weaviate, which specializes in vector databases. So let's actually see that solution here with their combined technologies. I had recorded actually the first 10 minutes of your keynote here, Greg, and I already fed it into the tool, and I asked it to summarize the video, and as you can see, this is the output that it came back with. Feels like a pretty good summary of it. Yep, sounds good to me. So what we're actually going to do now is actually ask it something more specific. What did CodePlay release? And so what it's doing now is the tool takes the multimodal inputs from text, images, speech, and video and structures that data into the same vector space. So now you can interact with it in natural language, and it will answer understanding the specific context of the data that you provided. As you can see, it found the answer. I think that's right, Greg?
That's correct.
And it found exactly where in the video you mentioned it. So what we're going to do is actually, it's going to bring it up here on the screen, and I'm going to hit play there.
NVIDIA GPUs, one API for AMD GPUs, and of course, one API for
Sounds
Intel
great, right?
GPUs. And the code
Yeah,
works
so,
seamlessly across
and remember that message, very important message as well.
That's right.
So they've developed this inferencing solution on the Intel Developer Cloud, and they developed it to use both the 4th generation Intel Xeon processor as well as the Max series GPU, and of course optimize it with Intel software. Pretty cool, right?
That's very cool. So I'll just throw out a challenge to all of us developers. Let's actually use large language models and technology like Copilot to write machine learning, train a machine learning model that can convert all your CUDA code to SQL. So you can start using Intel Developer Cloud today. I call it the try before you buy model. So you can jump in there. We give you a little freemium access to get in and play around. You can prototype, test, run your own AI workloads, experience the competitive performance of our platforms today. Give us feedback. We're always interested in responding quickly and growing and improving the capabilities. And there's no need for any setups, configurations, installations, or downloads. We put as much stuff there as we can. We have over 450 packages last time I counted. And bring your own and start using Intel Developer Cloud. That's what it's for. It's for you, from us, to give you access to our latest technology, and we'll keep it fresh and current and continue to expand it as demand demands. So in addition to those of you that are here in person, and we have made it easy for you to get started. If you actually look inside your package, your gift package, you'll see a cloud credit coupon there that you can use to basically get yourself some cloud credits in Intel Developer Cloud, and come and join all the other fun that the Liftoff program and many other startups and other companies that I can't name are doing. For enterprise users, we are announcing the Intel Developer Cloud Early Adopter Program, and the first 100 companies that register, starting now, within the next 3 months, will benefit from promotional pricing for a limited time. To qualify, companies just need to register for the premium or enterprise account at cloud.intel.com, and for the opportunity to receive credits for enterprises, you can request using the URL that you see there. Finally, you can gain hands-on experience for those who opt to get certified. You can join the Intel Certified Developer Program, which provides a full training curriculum via the Intel Developer Zone, along with professional credentialing with Credly badge. Build on your skills across a wide range of workloads, segments, starting with ML Ops and AI solution design as the first of a series of AI-focused certifications. And don't forget, we got lots of Xeons with data and AMX acceleration to get your data prepped, get your data ready. We all know you got to spend a lot of time doing that before you feed it into the training accelerators and deploy into an inferencing platform, whether on an accelerator or on a Xeon. So the Intel Developer Cloud is really just there to give you this latest hardware and code-optimized software into your hands. That's a great way to develop your own skills. It's important to get maximum performance from our infrastructure without compromising energy efficiency. India's largest homegrown social media company called ShareChat was experiencing exponential growth in a short period of time, seeing nearly 17 billion requests a day through their short video application. Their applications are deployed and scaled on Google's Kubernetes engine, spread across more than 50 clusters with over 200,000 cores deployed. But their rapid growth led to inefficient orchestrating, over-provisioning, and underutilization. They leveraged Intel's Granulate software, acquired by Intel in 2022, a scrappy, smart, hard-driving startup company that's now part of Intel, part of my organization, to optimize workload and application performance and reduce your infrastructure costs. And the results, they saw a reduction of CPU utilization and response time by up to 25% across all optimized services, leading to fewer cores being needed to run the same number of applications, and they were able to reduce their Kubernetes costs by 20% using Intel's Granulate technology. It doesn't require code changes. We do all the magic under the covers to basically accelerate those workloads. So Intel has also benefited from deploying Granulate software internally by dynamically optimizing more than 1,000 of our data processing jobs. And as a result, we experienced an average 25% reduction in memory utilization, 44% reduction in CPU utilization, using Granulate to accelerate our Cloudera analytic workloads, saving us a lot of money. We will continue to deliver enhanced features, especially Kubernetes optimizations, and we announced orchestration support for Databricks workloads, including Photon, to reduce compute and data center resources and provide an average of 30% cost reduction and 23% average processing time improvement without changes to code required. Check out the website in the QR code for more details and request a demo. And this technology is typically available in the AWS Marketplace and the Azure Marketplace. For over 15 years, Intel has consistently been the leading corporate contributor to the Linux kernel and collaborates across the open source ecosystem to deliver performance optimizations, technology advancements for the broader ecosystem. We also have a long, well-established collaborative relationship with the 3 leading Linux OS vendors, Red Hat, Canonical, and SUSE. Pick your favorite one. Distributions are often optimized for maximum compatibility going back to legacy platforms rather than to basically optimize for performance. But they may leave significant performance optimizations on the table. So you have to trade off compatibility across older generations and new generations for the performance that the newest generation can deliver, like our AMX accelerators and our 4th Gen Xeon, and what's coming in Emerald Rapids, Sierra Forest, and Granite Rapids. So we want to help you get the best performance out of our best platforms sooner rather than later. Today, I'm pleased to announce a deeper strategic engineering collaborations with Red Hat, Canonical, and SUSE to deliver Intel-optimized versions of their enterprise Linux distributions. This is a multi-year effort that we have aligned to their distro release cadence, so it's not disruptive to you, the customer. And when the Intel-optimized distributions are available, you will benefit from significant performance improvements out of the box. In addition, we have been working closely with our CSP partners to ensure that their custom-built Linux kernels are also highly optimized for our latest hardware, as they're the early adopters. And so let us hear from our OS partners directly. First, please welcome with me onto the stage Vice President and General Manager for the Red Hat Enterprise Linux business, Gunnar Hellickson. Gunnar.
Yes. Terrible. Terrible.
Hey, you got her?
Hey there.
Hey, how are you? This is cool. I mean, so I talked about optimized performance, but obviously we got to do that very carefully, right?
Yes.
We don't want to sort of disrupt your ecosystem.
That's right.
At the same time, we've got all these new innovations coming. We've just seen a couple of examples of it down the road, and so we want to be able to commit the upstream code.
Yes.
They'll call it the framework code that doesn't divulge some of our secret sauce too early.
Sure.
But at the same time, we want to make sure that before you do your major enterprise distribution releases, which customers depend on for reliability, et cetera, compatibility, that we get those those best optimized performance improvements in.
Yes.
So let's talk a little bit about how we'll do that together in the Linux ecosystem.
Yeah, it's interesting. We've been working together for over 20 years,
Yeah,
right?
exactly.
And it's been a close collaboration. You make delicious hardware with great features and great capabilities, and then we build this operating system, and then we deliver it to the market and encourage everybody to go use it. And you feel the same pressure that we do. We need to get these things into the hands of developers sooner, so that when we do our optimizations, when we do make these amazing performance improvements that we can do, that they are actually useful to the end user and useful to the developers that we have. And so we've been working for the last several months on a scheme, on a plan on how to do this, right? And it's coming in 4 flavors, right? There's basic kind of baseline performance improvements, foundational performance improvements. We're working specifically on AI, we're working specifically on edge, and then also on security, right? Shall I talk about those?
Yeah, well, so let's go ahead and jump into that.
Okay.
So it's basically it's a deep engineering collaboration. People know about our QAT technology, quick assist for accelerating compression, decompression, encryption, et cetera. But all that's really useful, when you start looking at more of the security context, because with TDX, which we've announced, our trust domain extensions, right, on our Sapphire Rapids and all of our Success and Xeon processors, this gives a whole new dimension and opportunity. I'll talk a bit more about it later. Let's talk about how we're working together to make sure that we get the right software pushed upstream for the TDX frameworks, and that you can then pull them down, just like the CSPs pull them down, so that we'll have the TDX, Trusted Confidential Computing capability, in the enterprise versions of Red Hat Linux.
Yeah, that's right. So we have through CentOS Stream, which is the midstream release of Red Hat Enterprise Linux. So this is, our source code goes from Fedora, and it used to go straight from Fedora into Red Hat Enterprise Linux, which was great for collaborating with folks like Intel, but not great for bringing in third parties, where Intel, Red Hat, and someone else have to work together before we release this software to the open public. So we created CentOS Stream, which is a place for exactly this kind of partner collaboration. And you mentioned QAT earlier. A great example of this is NGINX and F5 here on the show floor. They, working together with us through CentOS Stream, they have been able to get 178% performance improvement and a simultaneous something like 33% energy efficiency using QAT technology. It's fantastic.
Yeah. Power of software-defined, silicon-enhanced.
Right.
Let's also talk about sort of edge, because we have a great partnership with you and our OEMs, or some of our OEMs, to basically really enable the edge, where it's Intel's latest, greatest hardware at the edge. It's Red Hat, Kubernetes, containers for running those workloads at the edge. Again, getting all these accelerated capabilities and bringing TDX to the edge to secure those workloads running in the edge. Let's talk a little bit about how that's working out between us.
Yeah, so we're seeing great enthusiasm for Red Hat Enterprise Linux Device Edge as the platform. We are great fans of OpenVINO, and I saw here, once again, on the show floor here, Guys AI has actually taken all this stuff together, added in some security from both of us, security capabilities from both of us, to create a secure edge inferencing platform for industrial and manufacturing edge. It's really fantastic. So we're already seeing dividends from this collaboration that we've got.
And I mentioned TDX, but also there's our SGX earlier technology that's still available in the market and are currently shipping third generation Xeon processors.
Yeah.
And so we talked a little bit about TDX and security, but I got a little bit more to say about that later. So
Yeah,
thank you very much, Gunnar.
All right.
Appreciate the partnership.
Thanks very much,
and,
Greg.
we couldn't do it without being together.
Okay, thank you.
So, extending beyond cloud and enterprise to client and edge, let us now hear from my colleagues and good friends, Mark Shuttleworth, the Canonical CEO, and Brent Schroeder, the SUSE Global CTO.
Intel has long been one of the greatest contributors to the full open source stack. Intel has always taken an upstream first approach, and that's made it possible for distributions like Canonical Ubuntu to support Intel hardware out of the box. There's always a delay, however, in moving code through the upstream process, as there should be, and down to the distributions. So today I'm incredibly excited to talk about a new initiative where we've dedicated Canonical engineers working with their Intel counterparts to move the latest and greatest Intel software performance and security enhancing patches directly into Ubuntu, so that if you just run the current version of Ubuntu on your Intel hardware, you're going to get the very best performance from Intel's software R&D, combined with 10 to 12 years of Canonical security maintenance for that code if you put it into production. In doing so, we're really simplifying the process of becoming an end-to-end AI developer, making it easier to work with APIs like OpenVINO and OneAPI, and saving you a tremendous amount of energy, both in terms of finding, compiling, and optimizing your code, but also literally energy, whether that's megawatts in the data center or extra hours of laptop battery life. I'm excited to be building the future of open source on Intel with Intel.
SUSE, like Intel, is committed to openness and collaboration, every year contributing to numerous open source communities. Going forward, open industry collaboration is more important than ever to enable businesses to harness the power of data with open AI platforms. And with the proliferation of data, security is all the more critical. SUSE, Intel, and numerous others are focused on enabling confidential computing to ensure data is protected at all times in all environments. Together, SUSE and Intel are taking the initiative to deliver the most secure operating platforms, the most secure supply chain, and with that, the security in knowing that for every use case, openness, collaboration, and innovation underpin all we do.
Well, there you go. And, you know, this requires a lot of work by a lot of really smart engineers across these companies working together with our Intel engineers. But the result is so important that we have to do it, and we have to do it quickly. So we cannot discuss AI without discussing the importance of security and privacy. They go hand in hand and are ultimately converging. And I designed my own hand-in-hand t-shirt using a Venn diagram of ones and zeros, where we want security for AI, and we want AI for security, because machine learning is going to enhance the security of our platforms. We do it today. Our Intel threat detection technology in our client CPUs uses ML algorithms to basically detect bad signatures of malware code during the execution instruction cycles, and alerts Windows Defender to basically take actions against it. And we have the capability as well in our fabs to get higher yields. We use AI inside of our own factory facilities and drive better quality, better results, and better yields out of our systems. So, I'm the chief graphic designer as well for his t-shirts, except for Pat's. He does his own. So security for AI is leveraging security technologies to help secure the workloads, the models, and including the code, the IP, the data, all of it, and to promoting the responsible use of AI. AI for security, leveraging AI, as I just said, for security and privacy of products and services to increase product assurance. Because we all know nasty little zero-day vulnerabilities, happen all the time. Ransomware attacks happen all the time. And there's ways to basically protect and mitigate this using a combined hardware and software capability, which is really what our trust domain extensions and our SGX technology is all about. So this really means three things from our perspective, though, okay, because we are a fab, is establishing global, transparent, and trusted supply chains from the birth of the die off the wafer, all the way, eventually, we're not there yet, all the way to the motherboard, and so that we could basically give what I call the H-bomb, the hardware bill of materials. You've heard about this S-bomb, the software bill of materials, and ultimately we want to get to that level as well in the Linux Foundation through its open source security foundation is achieving that. So also investing in confidence computing then to protect data in use as it's running in memory and executing on our CPUs. So the risks of bad actors and these zero-day vulnerabilities and cybersecurity attacks are constantly challenging global supply chains. That's why at Intel, we've been offering the leading industry supply chain transparency and traceability solution through OEM partners since 2017, and expanding its capabilities now to account for the rapidly evolving landscape. Let's take a quick look with an animation to describe what I'm talking about.
Supply chain security is a concern across the public and private sectors. As technology grows more sophisticated, so too do the techniques used to exploit it. The industry requires a resilient supply chain, one that delivers traceability, transparency, accountability, assurance, and security attestation throughout its development and deployment lifecycle at a systems-level approach across both hardware and software. Intel's transparent supply chain offers visibility within the system manufacturing ecosystem and while in transit through the supply chain. First, it provides supply chain and manufacturing transparency and traceability for millions of systems per year. This includes details of the system and component level traceability, such as the component manufacturer, serial number, or system firmware BIOS, so that customers can identify certain system changes or evidence of tampering from the time of manufacturing to the time of first boot. Second, it verifies and certifies that the system is operating in a trusted state, generating the chain of trust based on the trusted platform module. But what if we could extend that transparency further back in the life cycle, say at the point of component manufacture, to provide transparency into the entire journey of the wafer or the software bill of materials? For example, providing data on chip design, lithography machinery, wafer sorting, assembly and test, and in software, the composition of our microcode, firmware and drivers to meet the regulatory requirement for security attestation of the software bill of materials. Even better, what if we could extend that transparency further forward in the life cycle? During customer deployment, customers may require that even cloud environments be verified by an independent third party to protect the value of their data and models in use in the cloud. Intel can help to independently attest the authenticity and integrity of the secure enclave in which sensitive data is processed and works seamlessly across multi-cloud environments. Together with our partners, we are building the chain of trust in a resilient supply chain that the industry undoubtedly needs.
So Intel's commitment to security goes deep into the hardware product assurance across our entire Intel portfolio, establishing this platform root of trust. Not only do we conduct our own proactive research and internal ethical hacking across our physical and remote attack vectors, but we also partner with some of the top industry researchers to try to break our products for us, and we offer a bounty program for ethical hackers to participate as well. If potential vulnerabilities are found, we then fix them quickly and mitigate them proactively. We do this for both pre-release and over the serviceable life of a product in its regular release cycle, and we release functional and security updates as part of a regular cadence via our Intel platform update process. And we do this on a regular basis to address vulnerabilities that might affect you and your businesses. The growing use of AI, though, has increased the amount of data, much of it being stored and accessed in the cloud. The industry has a huge opportunity to protect and maintain privacy of data and AI algorithms and models, as I've said, by using confidential computing, securing data in use by isolating it in a hardware-based enclave with an attestation service that's available independently to basically attest to the veracity of what you just saw here, is that the physical assets are basically genuine. They have not been tampered with, the firmware, the BIOS. You're up to date with the patch levels of all the IPU services that we provide. And so there's a growing need for data, algorithms, and models to remain encrypted throughout the whole end-to-end workflow process. This is known as confidential AI. Intel offers the most comprehensive confidence computing portfolio in the industry today, and will continue to expand our capabilities in response to always evolving needs for secure technologies. We collaborate with multiple parties on beneficial shared analyses while maintaining privacy and promoting compliance. I've already mentioned our SGX and our TDX technology, and TDX has been available in our 4th gen and is available in our 5th gen Xeon capable products in a way that keeps each party's data private and secure, even when you're running in a shared environment like a cloud, but the enterprise and even at the edge. And so operating at the VM level, the virtual machine level, Intel TDX offers strong security with greater deployability at scale, especially for our large enterprise and cloud customers. We're actively collaborating, as you heard, we're actively collaborating with the Linux partners, Red Hat, Canonical, and SUSE to enable these security technologies into the operating environment in their mainstream distros. It's going to take a little bit more time, but we're aggressively moving forward with that, as you heard. Several of our cloud service providers are assessing Intel TDX, and you can see behind me the various stages they're all at. And one of our leading deployment partners for many years between Intel is Google, and Google Cloud is now using TDX to enhance the level of confidence that their customers are demanding for the protection of sensitive data. But let's hear it from Google themselves. So I'd like to welcome the head of product, Google Platform, Confidence Computing Encryption, my friend Nellie Porter. Thank you. Thank you, Nellie.
Thank you so much, Greg.
So we've had a long collaboration on confidence computing. I can't tell you how many phone calls I do with Google engineers all the time. And through the Confidence Computing Consortium, again, we want to be open, transparent, and give the industry some understanding and choice about what they do. And so demand for confidence computing is expanding, but it's still early days. So tell me a little bit about Google's confidence computing philosophy, the approach you're taking to make sure that the platform is secure, and we partner with that with Google Zero. So tell me your perspective on that.
So again, partnership between Google, GCP, and Intel going way back. 4 years ago, 3 companies, Microsoft, Intel, and Google, come together to our Kirkland offices to talk about confidential computing and how none of these companies would be able to do it alone. So we agreed that we need to create confidential computing consortium back then and bring all of the companies to do it in open, and it's exactly what is uniting Intel and Google always to get this technology to our customers. 4 months ago, we published a very interesting paper. Maybe you will be interested as well to read, our developers. Intel and Google, our Project Zero, our the most well-known offensive security people, went and validated very deeply, again, pen testing and going very, very, again, deeply into the code, confidential computing, trusted domain extension, Former. And as we said, Former is the basis of our assurances to you, our GCP and Intel assurances in confidential computing, because only understanding how the whole entire system built from end to end, we can ensure you that your workloads, you developers created these workloads for our customers, will be cryptographically isolated when they deploy in GCP. But most importantly for us, those workloads, including AI, Gen AI, ML, when you're talking about models, applications, and data sets, will not be only cryptographically isolated in our multi-tenant environments, but also isolated against us, cloud provider, that's very critical for us to build the trust and build transparency. So we need to ensure that we will help you to build these environments. And one of the biggest things that Greg continued to endorse and talk about, these trusted domain extensions, you don't need to change your codes. You can run your application, your model, your PyTorch app without any code changes right there in those VMs. And simply by clicking the checkbox, you will make it confidential all through. It's exactly the innovations that we're looking from Intel and Google.
And at Google Next, you announced your C3 instances for confidence computing using TDX and customer preview.
Absolutely.
How do people sign up?
So we have signed up on our launch site. So please, please, please sign up. And we are ready to open this private preview for all of you. developers to give us feedback, to validate performance, scale, and usability of this technology.
Thank you for the partnership, and thank you for helping us bring this technology to the larger cloud market. Thank you, Nelly.
Thank you so much, Greg. Thank you so much.
Okay, so many data sets contain sensitive information and IP that are subject to heightened compliance requirements. I know I used to work in financial services, but healthcare, public sector, government, and increasing awareness in the general enterprise space, particularly the airlines and others, about the importance of the protection of this data in confidential computing. But it's not just about having the TDX and framework. You also want to have an independent attestation that the environment that you're running in Google Cloud or in, say Azure Cloud, where it's also available in customer preview, and these other cloud vendors that are getting closer to having it available. So Intel had previously announced Project Amber, and I announced it last year. After 18 months of hard engineering by brilliant engineers inside of Intel, we're now launching this as the Intel Trust as a Service model. It's called for confidential computing. This is going to give us the sensitive data processing, and it supports these zero trust principles by verifying trustworthiness of your confidential computing enclave, regardless of who's managing the data center, who's operating the environment. You, the customer, get control over that confidential computing environment and what software runs there and who has access to it. So today's announcement, and I'm excited to unveil, I almost unveiled it ahead of time, is Intel's new portfolio of security services called the Intel Trust Authority. And Project Amber is the trusted attestation service within the Intel Trust Authority portfolio of products, more of which you'll hear about over the rest of this year and into next year. The attestation service is the thing that gives you the integrity verification of the trusted execution environment and the policies that you set that say what is required of that environment before you'll allow your sensitive data applications to run and reside there. And I'm proud to disclose that we just recently achieved the ISO 27001 certification for this technology. We have done strenuous security testing, vulnerability testing, reliability testing to make sure this is an always-on service. And we run across multiple clouds. So this cross-cloud service gives you the ability to achieve that. And we have a beta version of this running in Intel Developer Cloud. It'll go live later this year in Intel Developer Cloud. So it's great to see customers and partners adopting this new Intel Trust Authority. And we've already been working with our partners to basically get them as the early adopters of this technology. So let's hear now from two security partners, industry partners, with real-world use cases, scary ones, who are using Intel's confidential computing systems and Intel's Trust Authority attestation service. So please welcome Vice President, Global Marketing, Cloud Protection, Licensing for Thales, Pupek Inbom. Thank you. So, Pupek, I'm excited to share. I wanted to share with everybody how you're using end-to-end data protection and data security with Thales Cypher Trust products. And you already have a great business, right? Very successful business, particularly widely deployed across enterprise and other large customers. So let's talk about, as people move workloads to the cloud, into, say, a confidential computing environment like with GCP or at Azure Cloud. Let's give an example of how we need to strengthen that security even further.
Yes, thank you, Greg. It's great to be here. Today, we are announcing Thales and Intel that we are joining forces to enhance confidential computing. What makes me most excited about this collaboration, though, Greg, as we discussed before, is that we are enabling end-to-end data protection for our customers' most sensitive data. Now, again, I can imagine you may think enhancing trust, end-to-end data protection. This sounds very much like marketing buzzwords, right? Not exactly. If we start with enhancing trust, this collaboration is based in one of the key requirements for data sovereignty, which is separation of duties, which Nelly mentioned before as well. With this collaboration, Thales and Intel are decoupling the control of encryption keys and the attestation of the trusted execution environment. That's paramount for the sensitive workload in the cloud to be processed. So that's the first one. Now, how does the end-to-end data protection work? If you take a look at what's displayed behind me, imagine we have a sensitive workload. This workload could be AI or machine learning algorithms written for financial sector to detect fraud. This workload is protected on-prem, which means it's encrypted by a key that was generated, stored, and managed by Thales Cipher Trust data security platform on-prem outside of the public cloud. This workload, if you want to leverage confidential computing, it needs to be lifted and shifted to the public cloud within the trusted execution environment. But before we can process the workload, the Cipher Trust agent will request attestation from the Intel Trust Authority, as we just heard, to independently verify the integrity of the trusted execution environment, the hardware and the software. If successful, and in addition, if the key policy that was set and defined by customer is met, then and only then the key will be released from Thales Cipher Trust data security platform, and the workload can be executed within that trusted execution environment without cloud providers being able to access it or see that. So as a result, now we have end-to-end data protection for that sensitive workload all the time, all the way during the life cycle, including when in use within the Intel trusted execution environment.
That's great. And this really takes a partnership to kind of bring all these pieces together to make it consumable by enterprises and by customers migrating their workloads to the cloud. Thank you very much for the partnership and
Thank you.
being on stage with me. Thank you.
Thank you.
So the shot clock just, I normally talk extremely fast, but I was coached to slow down by marketing. So we're almost out. We're running a little bit out of time, but basically, please welcome on stage Global Vice President of 5G Strategy and Zscaler, Dr. Ken Urquhart. Thank you, Ken.
Greg,
thanks for being here.
So
really appreciate, again, this partnership with Zscaler. Intel's a customer of Zscaler, so we're both partners, and I'm a customer. So tell us about this technology and how Intel's attestation service, combined with Zscaler, increases the security of your Zero Trust environments.
Absolutely, but before I do, you know it's a developer conference because we're applauding command prompts shown up on the big screen. Absolutely love this. So listen, we're all here adopting exciting new technologies, finding ways to work on them, but something's happening. More and more, we're dividing our apps and our solutions up across multiple private clouds, public clouds, edge compute clusters, end user devices, talking over fiber, over copper, over satellite, over Wi-Fi, over 4G, and my current favorite, 5G. We don't own most of that infrastructure anymore. We can't verify that it's secure. And that's where Zero Trust comes in. It's a way of operating. It's a complicated solution, too long to talk about here in detail. I can sum it up in one sentence. It's a way to make sure you can operate securely when you can't verify your infrastructure, your compute is secure. If we go to the next slide. Zscaler, we don't do firewalls and VPNs. We really simplify it for you. We absorb the complexity. We have put a little thing called an app connector against the parts of your solution. And the communication goes through the Zero Trust Exchange, which is a global cloud, to keep you safe. We monitor, we verify, we validate everything in real time. We watch all the parts of your solution that are so that they behave correctly, don't exhibit odd behaviors. And in doing so, we keep the good stuff in, your intellectual property, your customers' data, personally identifiable information, and we keep bad stuff out. That's malware and ransomware. We've been doing this for 15 years. We're the easy button. We process 300 billion to 400 billion transactions per day for our customers, pushing 18 billion petabytes, feeding 1 trillion signals into our AI ML. And yeah, we've been doing this for a lot of years to make sure you're safe. But there's a problem, which brings us to why is a guy who's doing 5G up on stage with Greg at Intel Innovation? Because in the telco industry, we moved from bare metal processing in own data centers, virtualizing, going into the cloud. And that's a bit of a problem. Why? Because we have a bit of implicit trust here. We're the virtualization layer. We trust it's secure. Now we're putting all this machinery in a virtualized environment we no longer control. And that's a problem. So I go to Greg and his team and say, Greg, yeah, the virtualization layer, we kind of have to implicitly trust it. And the problem with that with hackers, love it when you implicitly trust something, because that's where you're weak. That's where they attack you, because you say, I kind of assume it's safe. I can't validate and verify it. So it brings us to our partnership with Intel. Trusted domain extensions, TDX, the red boxes. That prevents the hypervisor from snooping on us. That prevents the virtualization layer. Because when you go that last few nanometers down from your app through the virtualization layer to the bare metal to do the computation, it can watch that path. It can modify it. It can shut it down. With TDX, you're now safe. You're sitting in a trusted digital enclave. But even that isn't zero trust yet. I need to prove you're sitting in that trusted digital enclave. And that's where Intel Trust Authority comes in. That's where the technology formerly known as Project Amber comes in. Because now I can prove that your workload, our connectors are operating in that safe environment and validate it. And because I can prove it and validate it in real time, anytime I want, anytime you want, I can apply rules. I can shut stuff down if it's not right. And that's the secret to zero trust. Always monitor. And I'm really happy that we've been able to solve this problem together, sir.
No, I mean, I remember I sat down with your CEO for lunch in Seattle about 14, 15 months ago, and we started talking about this, and it was like the light bulb went off immediately, how this could be applied in your environment. So thank you for the partnership.
The fun thing is being able to get there so quickly.
That's right, exactly. Thank you very much for being an early adopter and bringing this to market.
Thank you, everyone, and thank you, Zscaler customers out there. I know you're out there.
If you'd like to learn more, Ken and Pupak will both be back in the back to get some more information from them. So anyway, I'm out of time, but please give me, if you want to give me 5 minutes to talk about two important topics from Intel Labs. It's worth hanging around for that. So just give me a couple of quick examples of some things we're doing. We got an Intel Labs set of booths back there. You'll be able to see some of this technology back there. So the continuous innovation of these technologies, to keep pace with emerging threats. There's a next level of encryption we can go to. It's called fully homomorphic encryption. Let's just call it encrypted computing. It will take confidential computing and confidential AI to the whole new level, offering additional encryption solutions to support the variety of security needs. If you haven't learned about fully homomorphic encryption, you can easily find information about it on the web. And you can also go to the booth. I'm sorry, we don't have the homomorphic encryption booth back there. We have another booth back there for you. So basically, this is essentially a way to keep the data encrypted, but provide controlled access to it so that people can basically validate information such as your social security number, your credit card number, et cetera, without ever actually seeing the numbers. And so this is a really sort of interesting technology. There's one flaw, not a flaw, there's one challenge. It requires a significant amount of storage and compute because the original data gets inflated in order to provide this kind of secure access to encrypted data to basically process these queries successfully. So therefore, that requires special hardware accelerators, and we're working on a new ASIC to basically do this. So we have a little simulation here, which I'll just flip through really quickly, but basically, it's like confidential computing, but basically your data is your bank password, and we encrypt it, and we store it, but we don't decrypt it when somebody accesses it, like I just said. So with encrypted computing, the data in this new FHE techniques, as the source, the data is then sent to be processed, and the password comparison in this case is directly on the ciphertext. Because again, we're not decrypting it. You're comparing a request against a particular ciphertext by providing a set of credentials that basically authorize you to sort of do a match. And the match happens through a secure computational mechanism. So this is sort of an example of how we can do this with this technology, except this performance tax we have to deal with requires a hardware accelerator. So we're working on an ASIC accelerator to reduce the performance overhead, and we expect to see massive improvements in executing fully homomorphic encryption workloads on existing CPU-driven systems, which is key, and reducing the cryptogram processing time by 5 orders of magnitude. This is the big inhibitor to getting homomorphic encryption widely deployed, is this computational challenging problem, but who's really good at figuring out computational challenging programs? Intel Labs, and this is what we're working towards. Finally, the second example I want to touch on is quantum research. I talked about this last time. I mentioned I was teleporting my dog Jeffrey, back to his home planet. And today, in a simulator, my team took me literally. I didn't expect them to. They have a simulation of a teleporter as part running on our quantum computing SDK in Intel Developer Cloud. So go check it out. Users can build your own executables, simulating applications and algorithms up to 32 qubits on a single computational node, and we have more than 40 qubits if you use multiple nodes. So the Quantum SDK 1.0, which was in beta last year, is now ready. This is the launch of the Quantum SDK 1.0. It's available in Intel Developer Cloud. Again, you could go in for free and take advantage and use this, play around with it, and we're going to open up some capabilities to do this. Speaking of hardware accelerators for computationally hard problems, we released our quantum computing silicon spin qubit research chip, codenamed Tunnel Falls. It's the first Intel quantum research chip to be made available to the research community and will be used to advance quantum research and help Intel improve our qubit performance, and most importantly, its scalability, as Pat talked about. You got to scale to millions of qubits, and you got to scale to millions of error-correcting qubits to get to effective computational computing workloads. So in closing, I just want to say we're committed to open AI ecosystems, if that wasn't clear, because I think I said it 25 times, across multi-vendor, multiple architectures. We're providing you choice, productivities, optimized performance, trusted platforms, AI for security for AI, AI for security. We're unleashing the full scale of our AI portfolio via the Intel Developer Cloud for you to play, prototype, and don't forget to use your coupons. These are the endless opportunities how we can scale innovation in AI. Intel will continue to invest in open AI ecosystems to the level, the playing field for all of you, for all of us, to bring AI everywhere. Please visit the showcase and the cool stuff that's back there. I did it yesterday. Go check it out. Thank you very much.
What a keynote. Greg wasn't kidding yesterday when he said there was a lot to fit into 60 minutes and change. Let's get right into it. We're back on Innovation Live. I'm Madeline Littrell, joined by my co-host, Tony Mongkolsmai. Okay, Tony, there was a lot of news packed into this presentation. As a developer, what were your biggest takeaways?
Well, I obviously, as a One API evangelist, it's really great to see us transition to the UXL. So UXL is kind of a natural extension of what we were doing before. We're trying to build an open ecosystem around the One API specification. So I was really glad that Greg was able to highlight that. I'm really excited that that's part of the Linux Foundation. So for me, that was the highlight. But I do know, obviously, Madeline, that you have somebody on set that's going to tell us a little bit more about Intel Trust Authority, which I think is a big thing for other people, the launch of kind of our software service platform for confidential computing.
That's right. It is a big day for Intel Trust Authority. You know, it can be tough to wrap your head around the scale and scope of everything Greg touched on, but it really boils down to software progress and momentum. This one was highly technical in true Greg Lavender fashion. He covered a lot of ground, and that was by design, the progress from last year to today. We also saw hundreds of logos representing partners, customers, and foundations. And you can tell that this is really about an ecosystem working together. For example, the Unified Acceleration Foundation, that was a big moment, don't you think, Tony?
Yeah, absolutely. As I was saying, I was really excited about the UXL. You know, there's lots of things to talk about. UXL is great. All the confidential secure AI was great. All of the material was really driving us towards a place where developers are going to be really excited to use our platforms to kind of build what they really need to drive us forward. And again, you know I said it earlier, but Intel Trust Authority, it's such a big deal.
Absolutely, it is a big deal. And I'm joined on set now with Raghu Yaluri. He's the Senior Principal Engineer and Chief Architect for Intel Trust Authority. Raghu, thanks for being here. This is a big moment for you. Yeah, Intel Trust Authority was Raghu's baby. You wrote the original code, you pitched it to Pat. Can you tell us a little bit about that journey?
Yeah, absolutely. You know, 24 months ago we got this idea.
I got confused because the text was in the boxes, and I went to we were using purple for things where we were writing.
Talked to a bunch of customers, and we got a good feedback from them. And then based on that, we presented it to Greg and said, hey, here is a concept. Here is an idea that really increases the value of confidential computing. And he said, hey, I like it. Let's go pitch it on to Pat. And in December sometime, we made a pitch to Pat. You know, a whole bunch of us. We said, this is the concept. this is what it means to Intel. This is what the product is going to do. And Pat really liked it. He said, go build it. 18 months later, here we are, announcing it at Intel Innovation. So it's a very exciting and interesting journey for us. We had to build a team. It's a brand new service for Intel. Intel has never done this before. It's a software as a service. So we had to get the right skill set for the people. So we had to do a lot of good hiring of the right kind of folks onto the platform. We got them to build it, and it had to be agile. We had to get customer feedback all along the way. And this being a security product, security was paramount for what we did. So a lot of internal focus on multiple hackathons. We in fact did about 4 hackathons internally where engineers pretty much ripped it apart all the way from the foundation
that's nerve-wracking.
to the top. Absolutely it was. But we needed to do it.
It's important.
And then on top of it, we had to get a couple of external companies to say, hey, take a look at this code, take a look at the architecture, take a look at the design, break it apart.
Right. You said that security is paramount. And I think that feeds into this idea of confidential computing. Can you tell our audience, what is that?
So confidential computing is a new paradigm. Okay.
Right.
Today people are very good at protecting data at rest, data in transit. But when things are running in the memory of a platform, everybody assumes that it is safe. But in the cloud, in a multi-tenant environment, most of the data breaches happen when things are running in memory. Confidential computing, as defined by the Confidential Computing Consortium, it says run everything in a trusted execution environment that's hardware based. So you have integrity and confidentiality of what runs inside there.
Right.
Okay. There are 3 security properties for confidential computing environment. One is the trusted execution environment. Second one is integrity and confidentiality of what you run there. And the third one is what we call cryptographic attestation. Verifying that what you are saying it is actually what it is. That is the proof that every end customer wants before they can say, I'm going to run my AI model there.
Right.
I'm going to run my data there.
Right.
And that is what Intel Trust Authority is. It's an independent service that verifies the trustworthiness of a confidential computing environment.
And is that the true value proposition for these developers?
Yeah, for Intel Trust Authority, there are 3 vectors for value proposition. One is it's an independent service. You are not, the cloud provider is not the one that's providing you this service. It's an independent service from Intel that can verify the integrity of whatever you're running in a cloud. That's number one. Number 2, it's a turnkey service. You as a developer, you don't have to worry about bringing it together, putting it together. You just use the service. Make an API call, let the service do its thing. Okay? And the third one is it is cross-cloud. Okay, our mantra is the following, Madeline. Build it once, integrate it once, and run it in any cloud. With Intel Trust Authority, you can integrate confidential computing one time. You can run it in Google GCP. You can run it in Azure, Microsoft. You can run it in Alibaba Cloud. You can run it in IBM Cloud, or you can run it on-prem. If it is a very sensitive data set, you don't want to put it in the public cloud, run the whole thing on-prem. We can uniformly attest to that, irrespective of where it's running.
That's awesome. It's a seamless process.
It's a very seamless. We want to make it very, very easy for the developer. Typically, it's one API call. You make one call from your application, one from your workload, call into Intel Trust Authority. It does the rest of the magic for you. And if you're the paranoid kind and you want to know what it is doing, you can say, give me an audit report. And then Intel Trust Authority is going to give you the entire chain of trust. What did it verify? Which components in the Intel Trust Authority verified it? What was the result? When was the result generated? Everything is in an immutable ledger that you can audit.
I love it. Well, thank you so much for being here with us.
Welcome. Thanks for having me.
Congratulations, Intel Trust Authority. Your baby is born today.
Yeah, my baby is born, and I'm happy, and I'm going to go have a drink now.
Cheers to you. Cheers to you. Thanks again. And let's go to Tony to hear more from our showcase floor.
Yep, I'm here with James Reinders in front of our Intel Developer Cloud booth. And James, tell us a little bit about what's going on here with the demo in Intel Developer Cloud.
Well, I'm showing a bit of what we can do with Developer Cloud because, as a software developer, I love to have the latest hardware, but I I can't take it all home with me or to the office. So Developer Cloud gives me access to a lot of exciting things, whether it be the fastest new processors, FPGAs, GPUs, Gaudi, and we've got quite a selection here. We can go and log in and use SSH. I've got some code running here, and I've logged in. We also support using Visual Code. So I can either do that in the browser, or I can use Visual Code itself, the app, and I also have Jupyter notebooks available. And so it gives me a lot of different options. Also, on some of the instances, we have the software pre-installed, and others we let you install your own. So there's a lot of flexibility here, whether you're learning, training, trying out some new things, or developing large applications or large AI models.
Oh, that's excellent. And I want to shift gears because obviously you've worked on UXL. I know James has worked on this. Let's be honest, folks. He's been working on this for a long time. A lot of the work that we saw today on stage came from James's hard work with our friend Allison Richards, our friends at CodePlay. James, tell us how proud you are about how UXL has come along.
Well, I'm super excited because there's a lot of need for open software and open capabilities. We've just seen the beginning of acceleration in the industry. Even though it seems really exciting today, there's going to be more and more accelerators and acceleration capabilities in the future, really to drive the future of AI and scientific applications. And so UXL is focused on, well, how do we create open infrastructure that everyone can contribute to, whether they're working on designs that go into cars or designs that live in the cloud or on the edge. What can we do to make that a very open process?
Well, a lot of great work went into that. Again, I named many people who helped. We're really excited about it. Madeline, back to you.
Thank you, Tony. For our last guest, I have with me the chief geek himself, Intel CEO Pat Gelsinger. Pat, thank you for joining us. What a grand finale to have you on the show.
My pleasure to join you, Madeline.
It's been a full week. You're about to take your big exhale. Do you have any moments or highlights that stand out for you in the past 2 days?
Well, a couple from my keynote. I mean, clearly the idea of, bringing that glass on stage.
Oh,
yeah.
Cool.
It's sort of like, and everybody's sort of saying, what's he showing? Right. And I really love the rewind demo. Right.
That was so personal for you.
Yeah, it really was. And, obviously Dan and his hearing impairment and just how important that was to him and his journey and what really motivated him to start this company, Rewind. Yeah, but then you could sort of say, could I see myself using that on my PC every day? And the answer is absolutely, right?
For sure.
And frankly, I can see every person using it on the PC every day.
The same thing.
To me, and this, really stepping into the AI PC, generation. And, hey, at the end of the day, what do we do most of? Silicon. And just the array of silicon. Right?
To see it all up there.
All up there.
That was
and
a
of
cool
course,
moment.
the quantum wafer and, all of the things, it just, I had the hot one, Arrow Lake coming out of fab and the cold one at cryogenic temperatures. So, just the continued impact, and you pull that all together, and what do we say? Siliconomy. And just how we are enabling with what we do this entire reformation of the economic engines, how we touch every life on the planet, and all of that to me is very compelling. But it all happens because of developers, and that's why we're here, really enabling them and their best selves, right, as they want to unleash their passions for creating the technologies of tomorrow.
Oh, for sure. You talk about developers, and I said on the show yesterday that this is peak Pat. This is Pat as a developer talking directly to developers. You are in your element. So why is this event so important to you?
Well, from many, many years ago, I had helped to start the Intel Developer Forum.
Right.
And the company had stopped that, and to me, I was just, heart-fallen when that happened, because the role of the developer, because Intel's always been this open company. We've been driving the standards, the PCIe, the USBs, the Wi-Fi's, the software standards, and all of those, what do they enable? They enable an ecosystem to develop. And to me, as long as they were developing, our business was going to do just fine. because they're creating new applications, new use cases. And to me, if we're driving open standards and delivering the products behind them that enable them to become volume and deployed in the industry, that was always the heart of what kept pushing Intel forward. And when we slipped in technology leadership, we stopped leading the industry. And that combination then started to work against us. The ecosystems were going elsewhere. The innovation was going elsewhere. Now that we're getting back to our technology leadership, now it enables us to be re-engaging with the developer community, because that's truly where, as I said on stage yesterday, developers, you rule the world.
They do rule the world, and they do run this siliconomy. So what do you want them to do? What do you want them to take this technology and go do after today?
Hey, at the simplest statement is go crazy. Right?
Oh, go crazy from Pat Gelsinger. You heard it here first.
But it really is about, how they can take these things and say, what do I do on top of it? And hey, I was with one of the companies that were showing me how they're using CXL, for memory pooling and creating memory switches and so on. It's like, we might have gotten around to doing that software. We might have gotten around to doing that switch, but probably not, in it. But all of a sudden, you see multiple companies innovating in that area and coming up with new use cases. The dev cloud. How do you get on Intel stuff faster? Okay, this is the low friction, early, low cost way so that you can start developing. You have more choice, you have more flexibility to come up with those ideas. And I love the Ignite award winners that we showed off.
So cool, right?
Yeah, Intel in space, right?
Right.
With Anaris, and the Biofirma with Scala, and of course our winner with Deep Render, right. A 5x improvement. And this is a problem I worked on when I was working at
I know you heard that full circle moment. Right? That was so cool.
This is like 25 years ago. I was worried about H.264 and the importance of being able to have high compression technology. 5x and a lot more to come with AI and neural network techniques. It's like, okay, this is breakthrough. So quite excited they're doing that with us on our platforms, and give them this platform to expand what they're doing.
Right, it's AI everywhere and Intel everywhere.
Yes,
at the same time. Yeah. So let's talk about future developers for just a second, because your path to this chair and to that stage is not a normal one, not your typical path to CEO. So if you were to do it all over again, what advice would you have for the next gen? What would you get your hands on? What would you learn? Where would you start?
Well, clearly, and as I always say, the first, if you want to sit in this chair, be really good at where you are. Right, just become, known for, capable, distinguished in the area that you are. You got to be deep, and Intel as a technology company, deep in technology, getting really good and making a difference where you are. But then you got to get broad. And if you don't have that complement of other skills, be curious about other domains, learning about a broader set of things that enable you to be better when you go back and do your day job. Oh, I understand what marketing needs. I understand what sales might need. I understand, some of the financial implications. So that's what I mean by getting broad. And I always think of people, you should be a T. You really want to be deep in that area and differentiated there, but then you need to get broad and complement your skills in other areas. And to me, that's always the fun part. And when you come to a developer show like this, hey, I'm not an AI expert, but I'm a deep expert in certain areas, and I get to say, oh, how do I complement what I know with what they know? I'm not a software guy, but boy, now as I go and understand some of these things, I get a lot more breadth and understanding for those areas. And obviously, markets, world, geopolitics, there's just so many areas. So, if I could summarize it, be a developer and be curious.
Be a developer and be curious. And that's the magic of getting all these developers in one room, right? And really innovating together. That's the spark of true innovation.
Indeed, indeed. And of course, everything runs on Moore's Law. So their innovation combined with the core of what we do, enabling the Siliconomy, it's a powerful formula.
That's right. And you and I, we at Intel, are the keepers of Moore's Law, and we will charge on.
Indeed, indeed. It is alive and well until the periodic table is exhausted.
Is exhausted. Well, Pat Gelsinger, I'm sure you are exhausted after a couple of days, so thank you so much for taking the time to be here with us. It's truly an honor and a privilege to get to chat with you every year.
Hey, as always, Madeline, thank you so much.
Thank you. All right, let's get back back out to the showcase floor one last time. Tony, the showcase is just opening up. We see the attendees walking around. What are you going to check out first?
Well, you know, I was actually thinking about it. I think I might go back to the Modern AI Studio, get myself an avatar for next year, so maybe I'll have an avatar next year instead of being here, and then I'll probably head over to the hackathon area in the clubhouse and see how that's going.
I can't wait to see your avatar, but I enjoy seeing you in person a little more, so we'll see about next year. Even though this show is coming to a close, we have a full slate of videos and other content from Innovation at intel.com/innovation. There you'll see some of the Tech Insights presentations, along with other breakout sessions coming in the next few days. Hopefully, we've inspired you to push the boundaries of what's possible, create new opportunities, and create solutions to the world's biggest challenges. Thank you for watching, and we'll see you next year.